And we're live.
I don't know. I've heard better. Anyways, here we go. Good old Ann. Okay. Mark your own. Here we go. Total distance. Distance is a scalar. That's going to be 12 plus 16. That's going to be 28 kilometers. Or if you really wanted to impress me, if you got back to our standard SI units, no one did that, I'm sure, but anyways, 28 kilometers. Displacement. Now, displacement, that's the vector. That's going to have both magnitude and direction. And I see a compass, so I'm going to draw a little compass rose here. 12 north. Yoink. 12. 16 east. A little longer. 16. So there's the resultant. I'll call that D vector. I guess the magnitude is going to be d squared equals 12 squared plus 16 squared, and then square root. 12 squared plus 16 squared. Oh, is this going to work out evenly? Holy smokes. 20 kilometers, and then I need a direction. The direction is going to be where the vector started, which is right there. That's opposite, that's adjacent. Tan theta equals opposite over adjacent. I'm kind of hoping, by the way, hopefully during this unit, you're also becoming pretty good at trig. If it becomes like second nature boring, then I've done my job. It should almost be like sort of kind of in your sleep. All the people on the internet are going, what was that awkward pause? Someone had their headphone in their ear. Oh. Do you get 53 degrees? No, yeah? So 53 degrees. Now if I use the 53 degrees, that's going to be north of south, east of west, what of what? This is going to be east of north. Or I would take 90 minus 53, 37 degrees north of east. How do I give out marks here? I would give you a half mark for the vector diagram, adding them tip to tail. However, if you added 16 plus 12, in other words, if you went east first and then north, that's still fine. I would give you then a half mark for the magnitude of 20, a half mark for the 53 degrees, and a half mark for the what of what. If you got the right answer, you get 2 out of 2. You're fine. But that's how I break this down. Number 2, a motorboat question based on the lesson from last day. You know what? Oh, they tell me the river flows north. Which way does the river flow? So I'm going to dollop. I guess I got to draw my river like that because it flows to the north. It heads due east, so it looks like I have the motorboat pointing due east and the current flowing due north. We started out, oh yeah, we got, in your lesson, I actually gave you the resultant. We worked our way backwards and found the components. Here, I gave you the components, and I think the resultant is going to be, yoink, I'll call that V vector. In fact, I think V squared is going to be 18 squared plus 11 squared. I don't think this is going to work out evenly. Maybe it does. I doubt it. 18 squared plus 11 squared equals square root 21. 21.1 if you wanted to go to that far. I'll go, sure. V equals 21.1. That's a scalar. To make it a vector, I have to add a direction. North, east, south, west. So I could add that angle there, which would be tan of theta equals opposite 11 over adjacent, 11 over adjacent. Do you get 31.4? I'll go 31 degrees. So I would take at 31 degrees. What of what? North of south, east of west? What of what? North of east? Or I would also take 90 minus 31, subtract the 3, carry the 0. 59 degrees east of north. The other thing you could have said, I guess, is 59 degrees with respect to the shore. Same as before, by the way. Half mark for a good vector diagram, half mark for the magnitude, half mark for the theta, the angle, and a half mark for the what of what. And I hope you're getting that. I mean, that what of what is kind of tricky, but hopefully you're figuring out what the difference between north of east and east of north is. It's how it's done. When you wrap your brain around it, it's really quite clear, but you got to wrap your brain around it. B. Oh. I think they've given me a horizontal distance. They want me to find time. I'm going to use a horizontal speed. I'm going to use the 18, not the 12 and not the slanty. In fact, I think I'm going to be able to say t equals d over v. I think that's right because there's no acceleration. I think, Trish, it's going to be 155 divided by 18. Please tell me. I think the answer is 155 divided by 18. You get 8.6 seconds? People nodding? I guess that's a 1 marker, so I'll go all or nothing. Again, Manny, most common mistake, kids want to use the slanty velocity, especially if that's the one that I give you and it's not a decimal. For some reason, if I give them the components and they're not decimals, they're more likely to do it right. They just don't like using the decimal value. Well, live with it. Anyways, C, how far downstream? You know what? That wants me to find, I think, a vertical displacement. I know time is 8.6 seconds. I'm going to use a vertical speed, which happens to be the current, which was 11. I'm going to say dy equals vyt. 11 times 8.6. In my head, 900 and subtract the 46? I got to double check. Is it 946? Or am I way off? 94, not 900, 94.6.7. Forgot to, oh, good gosh. Move a decimal over, Mr. Dueck. Boy, that's preserved on the internet, too. 1 mark for that. So that page out of 7. Turn the page. A force of 100 newtons pushes 67 degrees west of north. Find the horizontal and vertical components of this vector. Okay. Let's see. I've turned the page, so I have to put a new compass rose on there. Trish, what's the direction that they gave me? Pushes, and then read the phrase after that. 67 degrees west of what? West of what? That's what I'm going to draw first. I'm going to go north. What of north? Which way would west be? Would I tilt to the left or to the right? I would tilt to the right. That's west. The other right, which most of us call left. Put your pen down. Hold your hands up like this, both hands. Which one makes the letter L? L for left, right? Okay, sorry. You guys knew that trick, right? Of course, the problem is, what if I hold them this way? Now this is, oh, yeah. So if I hear you correctly, and I think I finally do, you're saying I would tilt that way. You know what? It's going to look something like that. It's going to be 100 newtons, and this angle is going to be 67 degrees. We want the vertical and horizontal. By the way, don't write this down. You could go that and that. The problem is I'd have to figure out what that angle is. I could. Wouldn't it be 90 minus 67? I could. But you know what? I'll go yoink, and then yoink. So here is the vertical or northern component. Here is the horizontal or east-west, or in this case, western component. Fx is opposite sine 67 equals opposite over hypotenuse. I think Fx is going to be 100 sine 67. $92, 92.1, I'll go 92 even. Unit newtons. Fy, that's adjacent and hypotenuse. I think cos of 67 equals Fy over 100. I got more room? Yeah, I do. Fy is going to be 100 cos 67. $39.1. I'll go 39. How many marks is this worth? 2? You know what? How about 1 mark for that and 1 mark for that? Most common mistake I see, the one that drives me crazy, I'll see kids write Fx for Fy, and I'll see kids write Fy for Fx. What's an easy way that I can remember that y is vertical? Why do we use the letter y there? Why? I like that, eh? Why? No. Why do I call the vertical y?
Grid.
You're right, I think.
Graph.
Yeah, graphs. We pulled it from graphing. That's our memory trick. So just don't get them mixed up. In Physics 12, I kid you not, on the first test, we start with a review of vectors in Physics 12. And on the test, I asked them to find the components. And every year, I see kids put the vertical where the horizontal is and the horizontal where the vertical is. And I got to take off a half mark. Oh, and worse yet, I asked them to do something with it. And it means when they're solving something vertically, they're using the horizontal component. And their answer's wrong. And when they're solving something horizontally, it means they're using the vertical component. And their answer's wrong. And don't do that. Sled. Being pulled along the ground with a rope. Got it? The rope makes an angle of 75 degrees with the ground. You know, I didn't give you directions here. Let's just assume that we're pulling to the right and up. In other words, let's assume that there's the ground, there's the rope. 98 newtons and 75 degrees. And it wants me to find the horizontal, I'll call that Fx, and the vertical, I'll call that Fy. Components. Opposite, hypotenuse, adjacent. Hey Reed, you know what? I think Fx is going to be cosine. I think Fy is going to be sine. Yeah? Is it getting kind of repetitive? If it is, I hope so. It's kind of like, hey, this is not... Really only a couple options for components. I think you're going to find Fx ends up being 98 cos 75. Did I go too fast? And Fy ends up being 98 sine 75. Ends up being 98 cos 75. Does Fx end up being 25.4? I hope. Newtons, and Fy ends up being 94.7 newtons. And we also then, Halen, yesterday looked at how we could incorporate this into lawnmower questions. If I actually had a mass right here, you would say, hey, what's the normal force? The normal force is not mg. The normal force is going to be really small because Fy is canceling out some of mg. In fact, if the mass was small enough, if Fy was bigger than the mass, it would lift off the ground. That's how you are able to jerk something off the ground, even if you're pulling at an angle and not pulling straight up. It just happens to be that the vertical component was bigger than gravity. So, okay, it's got to accelerate up. Oh, I never thought of that. There we go. Last one. Hiker walks 15.6 kilometers at an angle of 65 degrees south of west. South of west? South of east. South of what? East. South of what? So I'm going to go east first. South of that, yep, that's the vector we're talking about. That's 15.6 kilometers with an angle of 65 degrees. Is this a force? No, this, you know what? Distance. I'll call it dx and dy. Dx is adjacent and hypotenuse. Cosine of 65 is adjacent over hypotenuse. .59, hey, 6.6 units, kilometers. I think dy is going to be the sine of 65 equals dy over 15.6. dy equals 15.6 sine 65. .1, is that right? Yeah. Kilometers. 2 marks. How about 1 mark for each of those? By the way, same as here as well. So 1 mark for that, 1 mark for that. Half mark off if you got the x and the y mixed up. 1 mark for that, 1 mark for that. Half mark off if you got the x and the y mixed up. Can you give yourself a lovely, lovely, lovely score out of 13, please? Any lawyering with me? Any glitches? Any questions? Now is the time. Sal, you're going to put a big omit on yours. Okay, so just you're going to turn it in. Pass them inwards, please, my children. Bear with me for a couple of seconds then. So your first bit of homework, this is what you absolutely want to have done for Thursday, is for next class, vector quiz number 2. It's got a couple of nasties on there. I've just given you velocity vectors and navigation. Let me see, 1 is good. So questions I'm going to assign. Number 1, absentively. Number 2 is good. 3 is good. 4 is good. Components. 5 is good. So far you've given everything. Shut up. Let's see. Oh, river question. Yeah, 6 is good. 6 starts out so easy that it's tough. The river current is south, and the boat heads south and heads north. So you don't necessarily get a vector triangle. It's either going to be south plus south or south plus north. I think you can probably just do that. Okay, so don't overcomplicate every year. I don't get that one. Don't overcomplicate that one. So 6 is good. 6C, now we're heading west. Now you might have to dulp a little bit as well. 7 is good. 8 is good. 9 is good. 10 is good. Mr. Dueck. A boat is headed, you know what? We can do 11. I know some of these I have to nuke, though, I think. A boat whose... No, 12 is good. Don't worry, you're going to get all class to work on it. Oh, hang on, I got to double check. Yeah, 12 is good. This is the one I'm going to nuke. Woohoo! Yeah. Woo! But 14 is fair game. So you have all class. What I have for you here, let me pause first of all.